So this circuit consists of two NAND gates. So each of these is a NAND gate. That means it's an AND gate with an inverter on the output. And there is some feedback from the output of the second gate into the input of the first gate. So let's quickly remind ourselves, what's the truth table of a NAND gate? A NAND gate takes two inputs, X and Y, multiplies them, then inverts the output. So anything with a 0 in it, when you multiply, you'll get a 0, and when you invert it, you're going to get a 1. And if you have two 1s, then you multiply, that gives you a 1. When you invert it, you get a 0. So that's the truth table for a NAND gate. For this circuit, they've given us three possibilities. Either both C and D are 1, or 0, 1, or 1, 0. So these are our three possibilities. Now, if C and D are both 1, so you've got a 1 going into the first gate and a 1 going into the second gate. So let's look at the possibilities. If C and D are both 1s, then if one of these inputs, let's say this input here, which is B, was a 0, then if any input to an AND gate is 0, the output is going to be 1. So you'd have a 1 at A. And if you have two inputs of 1 going into the second NAND gate, then the output would be 0. And that makes sense. That's the only combination that works. So for C and D both equal to 1, A and B would be 1 and 0 respectively. So that would be 1 and 0. Now, if we look at the next combination, 0, 1, so C is 0, D is 1, as long as there's any 0 going into a NAND gate, the output is going to be 1. So we know A guaranteed is going to be 1. Now, as long as A is 1 and D is 1, so the two 1s go into an AND gate, they give you a 0. So B is going to be 0. Our third possibility is that C is 1 and D is 0. So C is 1 and D is 0. So if you have a 1 and a 0, let's look at this first. As long as there's a 0, we know the output has to be 1. So we have a 1 there. So that 1 is going to feed into the input to this. So you have two 1s going into this. So the output has to be 0. So A is going to be 0. So it'll be a 0 for A and a 1 for B. So that's how I would look at a circuit like this.